Demonstrate what I hope to be doing this school year 2014-15 with our Parallax robots. So today I want to start with two robots that I've labeled, and I've given all our robots names so it's easier to follow as compared to last year. This robot is Einstein. Everything starts and ends with Einstein, and we'll also be working with Tesla to show how phototransmitters work. The phototransmitter is this right there, that little white clear light on top of my breadboard. Now that transmitter works an awful lot like some of you have motion sensitive lights at home, where if someone's walking on your in your backyard or on your deck in the back, the lights come on, and when there's no motion back there, the lights go off. Animals drive you crazy with that stuff. And a lot of the street lights are controlled by photo transmitters and receivers, so that when it's light out, the lights are not on, and when it's dark out, the lights turn on. That's all controlled by these photo transmitters and photo receptors. Now what Einstein is going to do is he's going to move straight. And from last year, you should know that straight is coded as 12,650 and 13,850. Pin 12 is right wheel, pin 13 is left wheel. The coding looks like this, and what is it telling us? Stamp 2.2, B basic 2.5, that's boilerplate, that's on all of our programs. Freak out stands for frequency out. It's directed to pin number 4 for 2 seconds. Give me a frequency of 3,000 hertz. And then it's going to say until IN6 equals 1, go straight. Straight is pulse out 13,850, pulse out 12,650. IN6 means that on the 6th input-output terminal, and you see I have a resistor attached there to P6, when the photo receiver receives a burst of light, that P6 is going to record it as function 1, and function 1 is going to tell Einstein to stop moving. Okay? So let's take a look, see if it works for us. Okay, I've already programmed it so I don't have to run from the laptop. So I'm going to hit reset, listen to the buzzer, should last for 2 seconds. It's going off. Now I'm going to shine a light on it and it stops. Okay, take it off, it's not going to move because I have to reset it. Okay. Okay, so Tesla's been programmed. He's going to follow my light switch here, my flashlight, and he's a little jerky, but that's okay. Overall he's following the light switch. So I turn it on, listen to the beep. All right, so I'm bringing it over to the left, to the right. I gotta hit that. Okay, so he is following the light switch. Now if I hold it straight, he should come straight towards me. Pretty much is. Now there's a lot of applications for something like this in the real world. I mean, you want robots, I could picture firemen who would want a robot that is looking for daylight, or even the Department of Defense, military might have some application for something like this, or miners, or tunnelers would like a robot that could work 7x24 just looking for daylight. Okay, so that's Tesla, that's robot number 2. So this is our next robot. I'm calling him Archimedes. Again, he is shooting IR photons out his IR cannons. They're really IR emitters. I call them cannons. The photons go out. If they hit a surface, they'll come back and hit the IR receivers. Archimedes is programmed such that when he sees an object, he is going to turn. If the photons come back evenly distributed between right and left, he'll turn one way. If they hit the right cannon, it'll turn the other way, one way, and if it turns to the left cannon, it'll turn the other way. So let's look at those three different options. Okay, so first, obviously, we're going to hear our beep, which tells us that it's programmed and it's ready to go. I think it's for 2 seconds at 3,000 hertz. That's freak out, 4, 2,000, 3,000. It's coming straight ahead, sees my hand, turns left, sees a hand on that side, turns left, sees a hand on this side, turns right. So those are the three options. Let's try one more. The next robot, he's Joule, J-O-U-L-E. He also uses the IR transmitters and the IR receivers, and just like Archimedes, and this is one of my favorite ones. Notice that the IR emitters are pointing down. Now he is shooting IR photons straight down, okay, and they bounce back up into the receiver plate. What's good about this robot is that if you put him on a tabletop, he will he'll revolve, he'll rotate on the tabletop, and when he reaches the edge of the tabletop, the photons will be shooting off the tabletop onto the floor below, so they're not coming back. So this robot is programmed to say move straight as long as the photons are coming back and hitting the receiver. When the photons are not coming back and hitting the receiver, you're at the edge of the table, time to turn around. So this is a nice robot. He'll stay on a tabletop, or he'll stay within an enclosed area. And first let me show you him staying inside a closed area. Down on the floor, I've marked off an enclosed area with black tape. Let me back out a little bit. With black tape. Now that could be considered the edge of the table. And Joule, because he's programmed to look down, will stay within that area. So whenever he sees the black tape, he'll move away from it. I may not have given him enough area. So you'll see he is staying within the black area. He will eventually get up out of that corner and hits just the right angles. But I think you get the idea. Now if that black tape was a tabletop, he would stay on top. You know, I have to make this area a little bit bigger so he has more straight distance to go. But I think you get the idea. Okay. So, our next robot is also an IR robot, shooting IR photons. His name will be Faraday this year. And he's probably just as interesting as the photon shooter. He is going to follow objects instead of avoiding them. So I'm turning on his motor. We get the frequency beep. Put a piece of paper in front of him. He backs up, or he follows. I rotate a little to the right. He's going to follow the piece of paper. Rotate to the left. Bring it towards him. Bring it away from him. So Faraday's got some nice applications here.